हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स एंड डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सुनी आपका हार्दिक स्वागत करता हूं जस्ट केमिस्ट्री वाला चैनल में रिगार्डिंग टू योर केमिस्ट्री। अभी तक हम बहुत सारी बात कर चुके हैं हेलो एल्केन और हेलो एरीन में। आज जो हम बात करने जा रहे हैं पर्टिकुलर एसिड रिएक्शन के टाइप की बात करने जा रहे हैं। एसिड रिएक्शन के बारे में हम पढ़ चुके हैं, न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन कहते हैं। इनमें पर्टिकुलर क्या क्या इंपॉर्टेंट चीज है उनको आज हम डिस्कस करेंगे डीपली। सो दिस इज द एसिड रिएक्शन. This is the SN reaction, means you can say nucleophilic substitution reactions की बात करने जा रहा हूं, reactions की बात करने जा रहा हूं जिनको हमने पर्टिकुलर शॉर्ट में कहा है SN reaction. SN reactions भी कहते हैं सब्स्टिट्यूशन बाय न्यूक्लियोफाइल, एसएन का फुल फॉर्म. और ये एसएन रिएक्शन आपके पास में फर्दर दो टाइप की मिलती हैं. एक होगी SN1 रिएक्शन और सेकंड होती है आपके पास में SN2 रिएक्शन. हियर SN1 पर्टिकुलर ऑर्डर को शो करता है कि रिएक्शन रेट ऑफ रिएक्शन पर्टिकुलर किस पे डिपेंड करता है, और यहाँ भी सेम SN2 पर्टिकुलर ऑर्डर को डिनोट करता है. पर्टिकुलर सबसे पहले बात करना चाहेंगे हम एसएन रिएक्शंस की. ये आ गए आपके पास में SN1 रिएक्शंस. SN1 रिएक्शंस की बात करूं तो पर्टिकुलर इनको हम यूनिमॉलिक्यूलर न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शंस भी कहते हैं सर. यूनिमॉलिक्यूलर न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन भी कहते हैं. यूनि मीन्स वन. इफ आई गो विद द जस्ट फर्दर देन यू कैन से जस्ट डेफिनेशन ऑफ द रिएक्शन मीन्स दोज रिएक्शन in which rate of reaction only depends upon only reactant molecules not to be attacking group. Those are known as just your SN1 reaction. This is the SN1 reaction. If I'll go with the property, this is the basic property of you can say 3-degree alkyl halide, या you can say those alkyl halide which forms just stable carbocation. Carbocation means having positive charge, जो कि पर्टिकुलर आप 11th में डिस्कस कर चुके हैं. देयर आर 3 टाइप्स ऑफ द कार्बोकेटाइन, 1 डिग्री, 2 डिग्री एंड 3 डिग्री. And 3 degree is the most stable carbocation. So it is the property of those alkyl halide which form stable carbocation as a just 3 degree carbocation. So this was about the just properties. If I'll go with the reaction, then we can take this is the CCS3. This is the CS3 and this is your Br. This is your KOH, we have discussed. This is the aqueous KOH. You can use NH also. As a nucleophile, here will formation of OH minus. Br minus will act as a leaving group, we have discussed. So this is also, this reaction also called as leaving group reaction. This is the CS3. This is your OH and this is your KBr. Here will formation of 3 degree butyl alcohol, or you can call it IPC name just 2-methyl propane tool. Now the time to discuss about the mechanism, which is very important. If I'll go with the mechanism, This is the mechanism of the reaction. First of all, it will breaking of KOH and here will formation of nucleophile OH minus. But in the first step, if I'll go with this reaction, then this reaction exists only two steps. Only two steps. What are they? First step is your formation of carbocation. This is the formation of carbocation. Listen me carefully. If I'll go with the reaction, then we can say rate of reaction depends on the number, just the concentration of the reactant. So both are the reactant. But if we'll go with the mechanism, then it will be totally different. Why, how and why? Listen me carefully. This is the 3-degree carbocation. See, here is the just a 3-degree alkyl halide as a tert butyl bromide. We can call it tert butyl bromide. If I'll go with the just electronegativity of Br is larger than the carbon, so here will formation of CS3. This is the CS3 and this is the CS3 plus and this is the Br minus. This step is slow step. This step is slow step. That is rate determining step, means जिसका हम rate determine कर सकते हैं. In the second step, that is the attack of nucleophile. This is the attack of nucleophile. Now here nucleophile is your OH minus. So what will be? This is the CS3, CCS3. This is the CS3. This is your plus carbocation. This is the nucleophile OH minus. So here will formation of CS3, CCS3, CS3 and OH as a you can say 3-degree or tert butyl alcohol. 3-degree or tert butyl alcohol. This step is fast. Why? Because of both are ion. This one is cation and this is the anion. And anion, just ionic reactions are the fast reaction. This was about the two steps. If I'll go with the just step, then we can say just slow step is a rate determining step. This is the slow step. Slow step is a rate determining step. Determining step. So what will be? But one thing is also important. If I'll go with the carbocation, then here is the carbocation with the sp2 hybridized state. And one thing is also its geometry is trigonal planar. Trigonal planar is the geometry. If I'll go with the just rate determining step, then that is the slow step. So slow step is this. So rate of reaction will be dx upon dt is proportional to the concentration of reactant. This is the concentration of reactant. So if I'll go with the concentration of reactant, then as a reactant here is the tert butyl bromide. So could I say this is the dx upon dt is proportional to this is the tert butyl bromide CS3 whole thrice C. This is the Br. Here is the only one molecule. So what will be? Here we can say that order of reaction is 1. That's why it is also called as SN1 reaction. SN1 reaction or just unimolecular nucleophilic substitution reaction due to having as a order first. One thing is also important. If anybody asks you what will be effect of just increase in the concentration of KOH on SN1 reaction, then remember one thing, rate of reaction does not depend on the just concentration of the nucleophile. So no effect will be on just rate of reaction for the SN1 reaction. But if I double the concentration to the alkyl halide, then rate of reaction will also double. So this was about the just SN1 reaction. We'll take reactivity also. If I'll go with the reactivity sequence for the SN1 reaction, then that is as follows. This is the reactivity sequence. What is that? Listen me carefully. And why that is so, we'll take also the reason. So you can say this is the reactivity sequence. Reactivity sequence, who is more reactive. If I go with the reactivity sequence, then there are three types of the alkyl halide: 1 degree, 2 degree, and 3 degree. So 3 degree carbocation forms more stable as a your, you can say, middle species as a carbocation. So 3 degree alkyl halide will be more stable, forms the more stable carbocation. So its reactivity will be fast. After then 2 degree alkyl halide, after then 1 degree alkyl halide, and after then methyl halide. This is the reactivity of alkyl halide regarding to SN1 reaction. This is the SN1 reaction. If I go with the just different methyl halide as a methyl iodide, methyl bromide, methyl chloride, and methyl fluoride, then you can say on moving up to down, it will increase in the size and bond length is also increases. So the activity of the just alkyl halide also increases on increasing size. Size of the iodide is larger, that's why its reactivity will be fast. Then the methyl bromide, then the methyl chloride and methyl fluoride. So this is the reactivity sequence regarding to your SN1 reaction. I'm again just writing here, this is the reactivity sequence for the SN1 reactions. And here is the important thing. What is that? Here is one of the sp2 hybridized state and trigonal planar geometry. So this was about the just SN1 reaction, and this is the most important part of this reaction, the sequence. It's a 5-star question, you have to learn properly. Now the time to discuss about the SN2 reaction. This is the SN2 reaction. If I'll go with the SN2 reaction, then these reactions are also known as bimolecular, nucleophilic. This is the nucleophilic, substitution reaction. Substitution reaction. This is the full form of SN2 reaction. If I'll go with the just this reaction, then we can say this reaction is the basic property. Basic property. Just you can say in other language, you can say those reaction in which rate of reaction depends upon concentration of both, you can say, reactant and you can say attacking group or nucleophile. Those are known as just you can say SN2 reactions. SN2 reactions. If I go with the just sequence and which exists more effectively, then as you know, just SN1 reaction, methyl halide shows very least. That's why this will be the basic property of these alkyl halide. So you can say, if you will go with the example, then you can take just CS3. This is the Br. Here is the KOH. You can take as a aqueous. This is the most important. You can take aqueous NaOH or KOH both also. Here will as a nucleophile OH minus. Electronegative group is so on. So here is the formation of CS3OH plus this is the KBr. One thing is also important, why 3 degree is more reactive, because of, as I told you, due to formation of the stable carbocation. If I'll go with this reaction, then this is the reaction. If we'll go with the just mechanism, Then this is the very important. So this is the mechanism. If I'll go with the mechanism, then mechanism exists only single step. Single step means leaving of group and and attack of nucleophile will nucleophile will just both, yeah, in the just leaving of group and the attack of nucleophile will just at a moment means particular न्यूक्लियोफाइल का अटैक, यहाँ तो न्यूक्लियोफाइल का अटैक नेक्स्ट स्टेप में हुआ और लिविंग ग्रुप पहले हट गया एज अ बी आर माइनस इज अ लिविंग ग्रुप, बट यहाँ पर्टिकुलर लिविंग ग्रुप का हटना और न्यूक्लियोफाइल का अटैक होना दोनों एक ही स्टेप में होता है. सो व्हाट इज दैट? इफ विल गो विद द स्टेप देन दैट इज एज फॉलोज. You can take over here and be with me properly because of it's too important. Without doing this you can't. So now the time to discuss about the just mechanism. The step is as follows. This is the C, this is the H, this is the H, and this is the H. Here is the Br, this is the Br. As you all know, electronegativity of Br is greater than carbon. So this is the condition of alkyl halide. Now the attack of nucleophile. So if here is the OH minus, then it cannot attack from the front side because of this one is negatively charged, this one is negatively charged. Here will repulsion. So what will be? It will attack from the back side. And due to attack of back side, what will be? Here will be a transition state. This is the C, this is the H, H, H. Here will the breaking of Br. Here will just attachment of OH minus. Now in this condition, just carbon remains pentavalent. That is not possible. So it will be unstable and dissociates in the product. So what will be? This will be formation of the C, and whenever it will removal of Br, then H, both three H will shift in that direction and it will change in the configuration of molecule. It will change in the configuration of the molecule and that is called as inversion. Inversion. This is the most important. Change in configuration. What is that? What is the meaning of configuration? I'll explain. And this step is a slow step. This step is a slow step. If I'll go with the just according to chemical kinetics, just you can say rate of reaction, that is your dx upon dt, is proportional to the concentration of reactant. Means rate determining step is your slow step. You can say here rate determining step is slow step and slow step is this one. So what will be dx upon dt will directly proportional to the concentration of reactant. This is the CS3Br and here will OH minus as our nucleophile. As we have discussed according to definition, means rate of reaction depends upon just concentration of both reactant and nucleophile. So this is the nucleophile and this is the just your, you can say, reactant molecule. If I'll go with the order of reaction, so order of reaction will be 1 plus 1, its order will be 2. That's why it is called as SN2 reaction. SN2 reaction. This was about the just SN2 reaction. If I'll go with the just inversion, one thing also, then inversion. What is the meaning of inversion? This is the best word regarding to change in configuration. If I'll go with the just optical isomerism, then there are two isomers as a D and L. If D changes in D form, dextrorotatory form, D form changes in L form. If here is the D, here formation of the L, and if here is the L, here is the formation of D, then you will say this configuration in molecule is called as inversion, and it was discovered by Walden. That's why it is also called as Walden's inversion. Walden's inversion. This was about the just change in configuration. You can say change in configuration of molecule. Configuration of molecule. Configuration of molecule. If I'll go with the reactivity sequence, then here is only hydrogen. In 1 degree it will be one of the alkyne, 2 degree here will also alkyl group, and in 3 degree here will also alkyl group. So attack of nucleophile, this is the nucleophile. Attack of nucleophile for the 3 degree alkyl halide will be slower because of here the more crowd. So you can say this is the nucleophile. So you can say here one thing, on increasing crowd, reactivity of SN2 reaction decreases. That's why reactivity sequence for the different alkyl halide will be just you can say methyl halide will be faster after than 1 degree, 2 degree and 3 degree alkyl halide as a alkyl halide. So if I'll go with the just methyl halide, then you can take methyl iodide faster, methyl bromide slower, chloride slower, and it will be slowest as a methyl fluoride. So this was about the just important part regarding to your SN1 and SN2 reaction. So we will meet with the just in the next video, particular with the new topic. Be with me, trust in the chemistry Wala channel, because it's totally free, no fakeness, everything is pure. पर्टिकुलर आप लोगों के साथ और विश्वास के लिए, ताकि ये उन बच्चों को मोटिवेट कर सके। ये चैनल इसका मेन मोटो यही है कि ये उन बच्चों को इजी वे में केमिस्ट्री अवेलेबल करा सके जिनके पास में फाइनेंशियली वीकनेस है और जो कुछ अपनी लाइफ में कुछ करना चाहते हैं। इसलिए इस चैनल को ज्यादा से ज्यादा शेयर करें, सब्सक्राइब करवाएं, ताकि उन बच्चों तक भी पहुंच सके जिन तक ये अभी भी दूर है। तब तक के लिए धन्यवाद, शुक्रिया। आपके साथ मैं विजय कुमार सोनी हमेशा आपके लिए तैयार रहूंगा। धन्यवाद।